These are the topics under chemical kinetics we're going to be covering today. We have definitions of terms, rate of reaction. Under rate of reaction, we have writing of rate expression. Now, how do you write rate expression for a reaction? And also, we have calculations involving rate of reaction. Moving forward, we have rate law or rate equation, right? We have orders of reaction and the rest of them. So, without wasting so much of our time or without further much ado, let's get into this. Let's look at definitions of terms. Which terms and which terms are we looking at for? Definitions of terms. Now the first term is, what is chemical kinetics? That's the first term. And the next one is, what is reaction mechanism? Alright, so we have this. We say chemical kinetics is a study of the rate at which a chemical reaction occurs. Now, the route through which the reaction proceeds is called a mechanism. Rate of reaction. We have rate of reaction. Can be defined as the change in the concentration of a reactant or product with time. So I would say mathematically, rate is equals to change in concentration all over time. Now this guy can be reactant or product. Right? This guy can be reactant or product. And the unit of rate of reaction, take note. Unit of rate of reaction is equals to, now this is concentration, which is mole per liter, and time is always in seconds. So this becomes mole per liter per second. So that is a unit of rate of reaction. Alright? Now, moving forward, let's see how we can write rate expression. Because in exams, they will not ask you this. They will actually ask you this regarding a particular quiz. Now let's take this first. Alright, give the rate expression for the following. So what we want to do now, I want to show us how we can write rate expression. Now if you notice, this first example here, all the reactants and the product, their coefficient is 1, 1. There are cases they will give a reaction and their coefficient will be more than 1, either be less than or greater than 1. Now let me state this. This is what we call rate of disappearance. Well, when I'm done with this, I'm going to tell us that. It's what we call rate of disappearance. Please note these words. Note this word. Don't write it down yet. Don't write. Disappearance. Disappearance. Decomposition. Consumption. These words are synonymous to reactant, or they are used particularly for reactant. If you're writing rate of reaction for a product, you have no right to use any of this for products. Now these three guys are mostly used for reactant. Now what about products? Now the opposite of disappearance is what? Appearance. Opposite of the composition is what? It's not composition, it's formation. I think these are the two words. Do we have any other word we can use for products? Which one? Yeah, we can use increase. This one we can use decrease. But I'm thinking how we can use this guy. Calculate the rate of increase. Very, very rare. So these are the common words. So take note of this. This is used mostly for, not mostly, this is used only for reactant. And this is used only for product. Now let's look at this. I'm asked to give rate expression for this reaction. First thing first, I'll come here and put R equals to, I have three reactants, one, two, three, two reactants and one product. So I'm going to say change for the first one. Now, anytime you're writing rate expression regarding reactant, you must always put minus here. So change in A all over the T. Now this is going to be equals to, regardless of the fact that there is plus here, equals to change. This B is also a reactant, you see also, so I put minus here. Now equals to, this C is on the product side, so you put what? Plus. Now, why do we put minus here? Because reactant is always decreasing and product is always increasing. Here is supposed to be B, supposed to have B here. So this is a rate expression for this reaction. Right? What if they had asked us to give the rate of disappearance of this? What if they had asked to give the rate of disappearance of this? Please, rate of disappearance can only go with either this or this, right? The composition, this or this. What was that last one? Consumption, either this or this. And then formation and the rest of them. So let's take another example. So the rate. Example of such we have 2A plus 3B giving us 4C. Now listen. Anytime this particular sum, I'm not going to give us notes to the because I'm recording it as well, so you can always fall back to it. Now, anytime you want to write rate expression for this, please, anywhere you have coefficient, it is always taken as reciprocal. That is 1 all over the coefficient. Meaning that if you want to write the rate of this reaction, this is going to be R equals to, for the first one, this A has stoichiometric coefficient, right? Reciprocal of 2 is 1 over 2. And since A is minus, it's on the reactant side, I'll start with minus. Because anytime you're writing rate of reaction involving reactant, you start with minus. So this is minus 1 over what? 2. Change in A all over the T equals to minus, since B is on the reactant side, 1 over 3. Change in B all over the T equals to, C is on the product side, 2 plus, and 4 is a coefficient, so you take reciprocal of 4, that is this. So this is actually how to write rate expression for this guy. Now once you understand how to do this, we're going to look at the next way question can be asked. That they can give us a question and you ask which of the following rates best describe or best define the reaction. So we have this. Give the rate expression for the following reaction. You just want to make sure that you understand or you know how to write rate expression. Once we are done, look at questions that can be asked under this guide. For the first one, for this first one, now this is actually a real reaction. We have coefficients on the hydrogen and also on the ammonia. So I'll have my R equals to, this nitrogen is on the reactant side. I'll put minus change in N2 all over the T equals to, the hydrogen is also on the reactant side, we have minus 1 over 3 now this guy is on the product side, we have plus now this is it. Now this is the rate expression for this guy, correct? Now the second guy, I just gave us that second guy to make us understand this guy better. Irrespective of the fact that this guy is a fraction, we shouldn't still change the concept. The concept says whatever the coefficient is, take the reciprocal of that guy. Reciprocal simply means 1 all over, right? But most of the times, in exams, you might see something like this class. Do you know that 1 over 2, 1 over 1 over 2 is something as saying what? Are you aware? Do you know that? 1 over 3 over 2 is something as saying 2 over what? 3. So take note of that. So in case you see that here. So for the second guy, my rate is equals to, now this guy is actually 1 over 2. So I'll say minus 1 over 1 over 2. But I'm not going to leave it this way. Right? 1 divided by 1 over 2, based on our indices, this guy becomes what? 2 over 1. Right? So this place now would be minus 2. This guy change into all over this. So 1 over 2 is 2. Now this is equals to, the next guy is 3 over 2. And we know that 1 over 3 over 2 is something as saying 1 divided by 3 over 2. If you actually compare this guy to multiplication, here becomes 2 over what? 3. Alright, so 1 over 3 over 2 is 2 over 3. So this is minus 2 over 3. Now this guy plus, because it's on the product side. Since there is nothing here, that is why if there is no coefficient here, you will not see, because 1 over 1 is 1. Just leave it as change. So that is the answer to that guy. Which of the following rate expression is correct for the chemical reaction? Now, look at this. I want to use this particular guy to explain something. You see, which of the following rate expression is correct for this reaction? Now, first thing first, you need to write the rate of this reaction first. So I'll say solution. Please stop writing. When I'm done, I'll just step aside for it to write. Now, the correct rate of this guy will be R is equals to minus change in A. Now, because A is a reactant, now equals to plus change in B. Now, this guy is correct. Why? Because this guy alone is this guy we have here. And with this, we can get our what? R. So this guy is correct. Now, the A is also correct. Because this is equals to this, which is what we have here. Is it not so? But our B is wrong. Can you see that? Why is it wrong? Because B is on the product side. Product is supposed to have what? Plus. But this guy is having a what? Minus. Have you seen why the B is wrong? So this guy is, this is the incorrect guy. Just in case you are wondering why is it incorrect, because in this rate expression, B is on the product side, so B is not supposed to have what? Minus. So this minus is what made this guy to be wrong. So that's the first one. Let's look at the next. Please write. So we have the next question that says, now, this is a question. Which of the following expression is incorrect? Remember what I told us earlier. For you to be able to get the answer, first of all, write the rate of the expression so that you have a reference point. Don't do it offhand. Some person might want, the time you use and be doing this, you must have used it to write the reaction. So please write so that we can solve this and then move to something else. The rate of the reaction will be R equals to A is on the reactant side, you put a minus. So this is 2 here, this is 1 all over 2. Change in A all over the T. Now B is also on the reactant side. minus 1 over 3 change in the B. Now this guy sees on the product side, we say plus 1 over 4 change in C. Now please bear in mind that if you see just any one of these as single, you see this just standing alone in the option, this is still correct because this is equal to our R, which is the rate in question here. If you see just this B alone, B is also correct, everything here, because this is equal to this. If you see this standing alone, it is still correct. However, if you still see two of them, maybe if you see the pair consisting of this and this, it is still correct. If you see a pair consisting of this and this, it is still correct. So what if they now give us this entire guy, it is still correct. Now, what are we going to be looking out for? Anything that does not correspond to what we have here. So first, option A is correct because option A is everything here. Can you see that? Option B is correct because option B is everything here. Option C is also correct because that is what we have here. Option D is also correct because minus 1 over 2A is equal to minus 1 over 3B, which is what we have. But however, option E is wrong. Can you tell me why it's wrong? Because this guy is supposed to have what? Plus. But what we have is what? Minus. So that is actually the reason why this option C, E is wrong. That's not the answer. So move straight to calculation. Please write. All right. We have this question here on the board. Right. Consider the decomposition reaction. Now, for this reaction, they said hydrogen was formed at the rate of this. All right. That means this is the rate of formation of hydrogen. Hydrogen was formed at this rate. Now, you're asked to calculate the rate of decomposition of ammonia, nitrogen, and of course, the overall rate of the reaction. So there are two ways we're going to solve for this. I'll solve using the direct method in a case where this question is coming up as a theory. And of course, I'm going to show the shortcut in a case where it's coming as OBJ or subjective. So whichever of these, you see in your exams hall, quickly adopt it. Are you all right? What's the time now? This 3 o'clock. What's your own time? 3 minutes past. So we still have like 4 hours to go. Don't worry. But before 7:30 I should be done. Right? The next 2 hours we should be done if everything goes as planned. Because I want to finish chemical kinetics today. Everything about it today. And I must do it. The department. But say this the amount today. The one kind of glass place of passports. Yeah. Alright, please look up. Everybody should look up. We have solution. Is this recording? Now the first thing first, this is what we're going to do. They gave us this reaction, and they gave us the rate at which hydrogen is being formed. So what we are going to do is that we're going to be asked us to solve for this and this, and of course the overall. So what you're going to do here is that please look up. First, this parameter given to me, I need to actually present it well. Now they said hydrogen was being formed at the rate of this. So we're going to say rate of formation of hydrogen. Please, if you actually convert this guy to mathematical expression of rate, remember rate is change in concentration all over time. And since it is hydrogen in question, rate of formation of hydrogen is this. Now, whether or not this formation is not here, rate of hydrogen, this is the definition of that guy, if you're asked to actually interpret this. But for the formation of this, that is actually where sign is going to come in, whether it's going to act positive or negative. But this rate, I gave us rate formula, change in concentration all over time. Hydrogen, because what we are referring to is hydrogen. But this formation here, this is how we're going to express the formation. So therefore, change in H2 is equals to plus, because they said formation and hydrogen is on the product side. It's going to be plus 0.062 mole per liter per second. What I did here is just to interpret what was given to me, because I'm going to use these guys to solve for other ones. Overall rate of this reaction is R equals to 1/2 change in ammonia equals to, sorry, there should be minus here. Now the overall rate is what we are writing here. Now this equals to minus change in nitrogen now this is equals to hydrogen is on the product side. Okay, sorry, both of them are on the product side, so I put plus here. We also have plus. Please, this is the rate of the reaction. So, based on this, we are asked to find that of ammonia, that of nitrogen, but guess what? They've given us that of hydrogen already. So this is what I'm going to clean this side of the board so that we have a clearer view of this. So the question A was, they said calculate the rate of decomposition of ammonia. Once again, try to interpret this word into the mathematical form. Rate in mathematical form is change in concentration all over. This is rate. This ammonia equation, since they mentioned ammonia, you include ammonia inside brackets. Now, this decomposition or formation can only be effected using sign. Right? Now, I do not have any value here. But it means that whatever the value of this ammonia will be, because of the composition, the answer should be what? Minus. So I'm just going to put question mark here. This is what I'm asked to find. Because they say I should find rate of decomposition for the A part. Now, looking at this overall equation. From this overall equation, ammonia is what I'm asked to find, this guy. And they gave me this from the question. I was told that the rate of formation of hydrogen is equal to this. Now, writing the overall equation, I can see that one of them is given to me, one of them is what I'm asked to find. So, class, look up. Do you know that this, since we have equals to here, this is equal to this, is also, and this is also equal to this, right? That means I can decide to equate this one, the one I'm asked to find, to the one I'm being given. Because it still equals, is it not so? So I'm going to rewrite, I will say, so therefore, rewriting this guy to incorporate ammonia and hydrogen, right? So I'll say minus 1/2 change in ammonia equals to plus 1/3 change in hydrogen. Do not forget that this has been given to us already to be equal to this, right? So anywhere I see that guy, I'll put this. So this becomes equals to 1/3 times 0.062. Please press your calculator for me. Hold on, let me write this. So we have what's the answer? 0.021. Right? But I was asked for just this guy alone based on this. So I need to remove this minus from this side. I need to remove the 2 from this side. So this is what I'm going to do, class. For me to make this guy subject of the formula, for this guy to stand alone, what should I do to both sides? You know, if I multiply this guy by 2, 2 will cancel this guy, right? If I will say multiply both sides by 2, look up. I want this guy to stand alone. Multiply both sides by 2 is not enough because minus will still be left behind here. You are going to say multiply both sides by what? Minus 2. So that minus will cancel what? Minus. The 2 will cancel out the 2. And that will be affected on this other side. So this becomes multiply both sides by minus 2. If you do that, this becomes, this guy will leave this guy. We now have minus 2 times 0.02, which is equal to what? Minus 0.042. Now for the C part, the rate of the reaction is very simple. Now you're asked to find for the rate of the reaction. Rate of reaction, you must write the formula. Now this is minus 1/2 ammonia. This is plus now look up. What this simply means is that you don't really need to write all of this. You can just pick just one of these and solve for your rate of reaction. So if you say, because for this rate, this is what you're asked to find for the last guy, right? Class, if you notice, rate of decomposition, the answer was negative. Rate of formation, the answer was positive, right? Please, for rate of reaction, that's rate of overall reaction. Rate of reaction should never be negative. The only one that is allowed to be negative is rate of decomposition, rate of disappearance, or rate of consumption, right? But the rate of the overall reaction should always be what? Positive. So here, I'm just going to choose one. This is equals to minus 1/2. Remember, that of ammonia gave us minus 0.042. Is it not so? From our calculation. Now, that of nitrogen gave us 0.021, right? And that of hydrogen, they gave us to be 0.062. You notice that if you evaluate everything here, it's going to give you the same answer. Minus minus is plus, 2 divided by this, so this is 0.021 equals to 0.what? Equals to 0.021. So you don't need all of this in exams. In exams, just choose one of this. Just choose one of this, insert the value and do what? Solve. So the overall rate of this reaction is 0.021 mole per liters per second. I'm going to give us shortcuts on this, and then one last example, after which we move down to orders of reaction. Okay, short form of solving rate of reaction calculation. So we have this. It's okay. Now, if you look at this ratio, first, this is what you're going to do for yourself. This guy is on the reactant side, right? Can choose to put here to be minus, or let's just say minus, plus, and what? Plus. I believe you know why I'm putting minus, right?
Yes.
Because reactant is minus. Now, can choose to do it this way. First, the coefficient is 2:1:3. Now, since ammonia is on the left hand side, we put minus here, right? And since this guy is on the product side, I'll put plus. I'll put plus. This particular one, you can decide to keep it away. Once you get your final answer, if it is for that of ammonia, you add plus in front of it. If it is that of product, you add minus and add plus. So this 2:1:3. Now look up. In that question, they gave us rate of formation of hydrogen. Is it not so?
Yes.
No, so you come under this guy. They gave us this guy to be 0.062. Finish. So I would say for the first one, for A, I was asked to solve for ammonia, right?
Yes.
Come here, under ammonia, put what? S. Cross multiply. Right? Now this becomes x. This becomes 3x. 3 times x is 3x equals to 2 times 0.062. If you make x subject of the formula, x becomes 2 times 0.062 all over what? 3. 2 times this is what? 0.12. So if you do this, this will be 0.042. Now, since ammonia is on the reactant side, you put what? Minus. This is the same answer as what we got in our calculation. Check your notes. True or false? So imagine if this guy was actually in theory OBJ or subjective section. Then you cannot just go and start doing that long procedure. Me, I will never try it, except it's theory, where I'm very, very sure that my solving will be rewarded. My solving will not be rewarded. I won't do that. Alright? I'll do no sure thing. So, any question on this? B part, they asked us, please. The B part, the question the B part was for us to solve the rate of formation of nitrogen, is not so. So here, I'm going to make this guy subject. Why? I'll put y here. It's very simple, cross and multiply. So therefore, y, which is the rate of formation of nitrogen, becomes equals to 0.062 over 3. I believe you know how we got this. But for those persons that may be wondering how I got this, first you cross multiply. 3 times y will give us 3y. 1 times this will give us 0.062. We make y subject of the formula, we have 0.062 divided by 3, which is 0.021 mole per liters per second. So that is it. Now for the last one, this part. Now the question number 2 says, Alright, so we have a question here. They say the decomposition of N2O5 proceeds according to the following reaction. Now, 2 molecules of this give rise to 4 of this plus this. They say if the rate at a particular instant is 4.2 times 10 to the power of this, please this molar is something as a mole per liter. Now, what is the rate of appearance of A, this, and B, this? I'm going to solve the direct method, then I'll leave you guys to solve the shortcut. Now, solution. Now remember, before you're asked to solve for rate of either of this or this, they must have given us one of them at all. In the previous example, they gave us that of hydrogen, and we asked to solve for that of ammonia and nitrogen. This time around, we have been given the rate of N2O5, and then we are asked to solve for the rate of appearance of this. So let's get it straight. Rates of, they said, if the rate at a particular instant is 4.2 times 10 to the power minus 7 molar per second for the decomposition of N2O5. Please, this singular statement is equivalent to saying rate of disappearance or rate of decomposition of this guy. That's it. So I'll say rate of decomposition of N2O5. Now, this is equivalent to, we'll put it in a mathematical form so that it will be easy for us to be moving about. We have N2O5 all over the T equals to, they gave us a value. They gave us this guy to be 4.2 times 10 raised to the power minus 7 plus. But listen up. For the fact that they said this guy is decomposition, right? You must add negative to that value. If you don't add negative to that value, you can never get the right answer. So here, because of this statement, decomposition goes with reactant, isn't it also? So you must add minus here. I did not say you will add. What did I say? Must and will. What's the difference? Must is setting. Will is optional. Right? Will is not optional. But will does not express certainty. Must express certainty. So you must add this. English is hard. But if you understand, it is very easy. Alright, so that is it. We've interpreted this guy. Alright. So the question says, let me take off this part. The question says, what is the rate of appearance of A? So I'll say A, what is the rate of appearance of NO2? Now, converting this guy to mathematical form, I don't have to start saying rate of appearance. I'll simply say rate is always this. Now, since it is that of NO2, NO2 is on the product side of this reaction, so we are expecting our answer to be what? Positive. Is it also? Now, let's solve for this guy first. Then when we are done, we look at that of nitrogen. Class, if you write the total rate of reaction for this guy, overall rate of this reaction is R minus 1 over 2 change in N2O5 all over the T equals to plus 1 over 4 change in NO2 plus now this is it. Now, but in this question, I'm asked to find NO2 and I was given N2O5. So look at this overall equation. Let's relate the two stuff. You're going to relate two things, the one you're being asked to find and the one that is given to you. They gave us N2O5 and I'm asked to find this. So therefore, I'm going to relate this and this. Is it not so? So in this first instance, I have no business with this second guy. So this becomes, so therefore, I can decide to rewrite this so that this NO2 will start first, because this is what I'm looking for. Is it not so? Or should I start with this guy first? Which one should I start first? Eh? Alright, so we say minus 1 over 2. See the same thing? Equals to, this rain is raining somewhere. It's very heavy. Alright, so now look at this. I want to take out this top part. So let's substitute this guy. If you want to substitute this, this becomes, so therefore, minus 1 over 2. Now this guy was given to us already to be minus 4.2. So this is times, we can just say minus 4.2 times 10 raised to the power of minus 7. Now this is equals to plus 1 over 4 minus minus is plus, this divided by this, 4.2 divided by 2 is 2.1 times raised to the power of minus 7 equals to this other part is mathematics. You can, if I'm the one solving from here, I can get my answer directly. I don't need to do all of this. So now look up. We want this guy to stand alone. So we're going to multiply both sides by 4. Multiply both sides by 4. That is the answer. Alright, please stop. Now this particular question is kind of different from the ones we just solved previously. Right? Now they say, consider the reaction 2Q plus CDY, blah, and the rest of them. Right? The following rates we obtain as the concentration of the reacting species. Now they gave us the rate of this guy. Rate of Q is 0.05. Rate of Y is this, rate of I and rate of T. Now, basically what they are asking us to find is these coefficients here, C, S, and T. Now, so there are various ways to solve this. You can do it in a longer method, or you can use a shorter method. So I'll actually go with the shorter method. Solution, please look up. This is what you're going to do. They give us, we have 1, 2, 3, 3 unknowns. This C is what they are asking us to find, C, S, and T. So this is what you're going to do. You're going to actually equate or compare this and this together. Right? Because you know the coefficient of this guy. So this is what you're going to do. You're going to say, for C, solving for C, you say, this C, the species attached to this C is what?
Y.
Rate of Y all over rate of Q. This all over this equals to coefficients of Y all over coefficients of Q. Now, the rate of Y in this question was given to us to be this. So say 0.15. Rate of Q is given to us to be 0.050 equals to coefficient of Y. This is Y. C. Coefficient of Q is 2. If you cross multiply, your C becomes equals to 2 times this divided by this. So this is 2 times 0.15 divided by 0.05. Please, what's the answer? Your calculator, please. 6. Alright, so that is it. So C is 6. So this is actually how we're going to get it. When I'm done with C, it's either I use this guy to get this, or I can still equate this one to Q. So please write so that we can solve for S. I'm going to solve for the S, and then later you solve for the last one. Now for the S, now I now know this guy to be 6, right? So I can either choose to equate this one to this, or I can still use this guy. Do you understand what I mean? So this is what I mean. This is the one I'm looking for the coefficient. So I'll start with the rate of this. I'll say for the X, I'll say rate of F all over. Now I can choose any of these two because I know their coefficients now. Right? But let's just stick to this Q. I'll say all over rate of Q. Now, there is no need of writing the coefficient, you do not know. Now, coefficient of F is what? S. All over. Coefficient of Q is what? 2. Now, what is the rate of F in this case? This guy. So we have 0.075. Rate of Q is what? 0.05. Now, this is equals to S over 2. Then if you cross multiply, it should give us 3. So this is S equals to 2 times 0.075 all over 0.05. And S is equals to what? 3. So you definitely solve for the last one. The last one should give us 1. So let's look at rate law. Alright, please go. I said rate law is also known as rate equation. Like I said, it's an equation that relates the rate of the chemical reaction to the concentration of the reactant. Okay, now this is actually the reaction, the equation that actually tells us how much rate will actually increase if we increase the concentration. Now, let's assume, for example, I have this equation like this. This equation has only one reactant. So the rate law for this guy, or rate equation for this, is going to be R equals to K, A, raised to the power of X. Now this X is what we refer to as order of reaction. Now this X is actually not the stoichiometric coefficient here. Now, we actually wrote only A because this guy has just one reaction. Now what if in a case where reaction have A plus B giving us C? The rate law for this guy would be K equals to A raised to the power of X and B raised to the power of Y. Now, this X in this case is actually the order of the reaction with respect to A and also the overall order of the reaction. Now this guy, this X is order of reaction with respect to A and Y is order of reaction with respect to what? B. Now, some of the exponential term or some of the powers on the concentration term. Listen, if I sum up these powers, so therefore, X plus Y is equals to overall order of reaction. So basically, this is actually what we mean by rate law. Okay, I'm only interested in the reactant. I have no business with the product. Now this shows that if you increase the concentration of this guy is going to increase. Now listen, if the sum of these powers, if you add up X plus Y and it's equals to 0, that reaction is a zero order reaction. Is a what? Or in this case now, this is actually two different equations. If you're considering this guy, if X is equal to 0, this guy is a zero order reaction, which means that the rate is independent of the concentration. It becomes 0. Anything raised to the power of 0 is always 1. Alright, so if X is equal to 0, and of course you have something like this, it means that anything raised to the power of 0 is 1, right? That means rates for a zero order reaction is independent of the initial concentration. That means if you like, increase the concentration from now to tomorrow. If the reaction is a zero order reaction, the rate is not going to increase. Right? It's more like independent of this guy. So take note of that. If X is equal to 0, that's zero order reaction. If X is equal to 1, that's first order. If x is equals to 2, that's second order. If x is equals to 3, that's third order. Now that's for the case of a reaction having just a single reactant. How about if we have sometimes have 2 or more reactants? Of course, that would give rise to 1 or more, 2 or more exponential terms, right? If you add these two guys together, these two guys gives us 0, zero order reaction. If it gives us 1, a first order. So please take note that the sum of the powers in the exponential, the sum of the powers in the concentration term, please put down. The sum of the powers in the concentration term of a rate law is called the order of the reaction. The sum of the powers in the concentration term in a rate equation or rate law is called the overall order of the reaction. It's called the overall order of the reaction. Now there are various ways you can ask those questions. Please look, we have a question here. Now this is actually very similar to what I gave us previously. The sum or the total of the powers to which the concentration terms are raised in the rate law is called what? Overall order of reaction or order of reaction. It's the same thing. Order of reaction or overall order of reaction. So the answer to this question is overall order of reaction or simply order of reaction. Alright? Now, look at this guy. He said, given the empirical rate equation, right, this, he said calculate the overall order of the reaction. Class, remember, overall order of the reaction is actually obtained by adding the powers. Is it not so? So look at this guy. The first one is 2 alpha plus 0. 0 is actually, you can ignore 0, right? Alpha plus 2 alpha will give us what? 3 alpha. So the answer to this guy is 3 alpha. I don't care what the alpha value is. Alright, so that's the concept behind this. You just sum the powers here and you're done. Now this last guy is kind of it's the calculation part, but let's quickly run through it. Now look at this. They said a certain reaction has rate constant rate equation of this. They said the rate of the reaction, which is the R, is equal to this. When this guy is 0.2 and y is equal to this, they say calculate the numerical value of the rate constant, which is the k. So first thing first, from here, if I make k subject of the formula, this becomes R all over Q squared. So I'll come here, they gave me the value for R to be equal to this, to be 2.5 times 10 to the power minus 4, right? Now, my Q, they gave me to be 0.2. And then my Y, they gave me to be 0.05. But remember, this Y was raised to the power of what? 2, so you have to square it. So please, what's the final answer here? 0.5. Now you may be wondering how I got the unit. Now, how did I get this unit? The answer is 0.5 molar. This capital letter M is mole per liter. So it's molar raised to the power of minus. So how did I get that? Look up. The R, let's do the unit evaluation. Just look up. The R has a unit of molar per second all over. This Q has molar. And this guy has molar as well. But the molar is raised to the power of what? 2. So this cancels this. Right? When this guy becomes up, it becomes minus. So that's how we got molar. When this one comes up, it becomes what? Minus 2. And then per second. That is how we got this. So that's the answer to that question.